All right, this is lesson 3, theoretical and versus experimental probability. In the previous lesson, you saw that to find an estimate of probability of an event for the chance experiment, you divide, okay, or you set it up as a fraction. I have a bag with some cubes colored red, green, and white. The cubes are identical except for the color, and I will conduct a chance experiment by randomly drawing a cube with replacement from the bag. I'm going to record the outcome of each draw in the table below. So let me make sure I've got my table here so that I can draw them out. So I'm going to be picking them out. I've got red. And I've got white. And I've got white. And I've got red. And I've got red. Red. And I've got white. And I've got green. And I've got red. And I've got green. And I've got green. And I've got red. And I've got white. And I've got green. And I've got green. And I've got red. And I've got green. And I've got white. And I've got green. And I've got green. Okay. So now the question on the next page says, choosing a white cube, based on the 20 trials, estimate the probability of choosing a white cube. So out of the 20, I've got 1, 2, 3, 4, 5. So I have the probability of white was 5 out of 20, which is 1/4. Okay. So the next question says of choosing a green cube. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8 green cubes. So I have the probability of green is 8 out of 20, or 4/5. And the probability of red is 1, 2, 3, 4, 5, 6, 7. Which is 7 out of 20. And that is my experimental probability. So question number 2 states, if there are 36 cubes in a bag, how many cubes of each color are in the bag? Well, there would be 12 of each. Since an equal number of each color is estimated. It says if your teacher were to randomly draw another 20 cubes, one at a time, and with replacement from the bag, would you see exactly the same results? No. because each one could be different. Okay. So next it says, find the fraction of each color of cubes in the bag. Okay. So out of the 36 for the white, it would be 12 out of 36, or 1/6, or sorry, 1/3. 12 out of 36, which would be 1/3, and 12 out of 36, which would also be 1/3. So it says, is each color equally likely to be chosen? The answer is yes. There is the same number of cubes for each color. Okay. So now it says, theoretical probability is based on theory. Okay. And theory is, we'll talk about in a minute. Experimental probability is based on experiment. So it says, how do theoretical probabilities of choosing each color from exercise 4 compare to experimental probabilities you found in exercise 1? Well, theoretical is what should happen. Okay. And experimental and forgive me for spelling experimental wrong. Sorry, guys. Is what actually happens. Okay. The probability of tossing heads or tails is 1/2. This is called theoretical probability. Based on this information, how many times should we toss a tail if we flip a coin 50 times? Well, that should happen 25 times. Okay. Is this guaranteed to happen every time we conduct the experiment? The answer is no. Because when you conduct an experiment, that may not happen. Let's take a look at the simulation of flipping a coin on a virtual app. And we're going to be going to this app in class, okay? And it will show us what will happen. And then we will check it out between 100 times, 500 times, and 1,000 times as to what will happen in this app, okay? You can actually go on to this app and do the exact same thing, okay? So then So now we've got, excuse me, the graph shows the results of an experiment in which a spinner with 3 equal sections is spun 100 times. Find the experimental probability of spinning red for this experiment. Well, here is red, and we see that we have 62, 29, and 9. So when we add these two together, or 3, we have 62, 29, and 9. So when we add these together, we get 100 times. So that is our total, that is our denominator. So the probability of red is 62 over 100. And then we would simplify. To compare the experimental probability you found above to the theoretical, our theoretical then would be 1/3, because there are 3 things here, times 100, okay, would be 33. So theoretical would be 33 over 100. So the experimental is much higher than the theoretical. Okay. So next we have a coin that is tossed 50 times and lands on heads. Sorry. "28 times. Find the experimental probability and the theoretical probability of a coin that lands on heads. Then compare the experimental and the theoretical probabilities." Well, if it lands on heads 28 times out of 50, that is 14 over 25. For it being 50, it should land on it 25 times out of 50, because it's half, and it still would be 1/2. So here the experimental probability is higher than the theoretical. Probability. Okay. So next, we have the graph shows the results of an experiment in which 2 numbered cubes were rolled 50 times. Find the experimental probability of rolling a sum of 12. Well, here we have, here's the sum of 12, and if we go over, it's 3 out of, if we add the frequencies up, it says that it's 50 times here. So 3 out of 50 times. And it says compare the experimental probability to the theoretical probability. Well, to do to roll a sum of 12 would be 1 out of 36 times. And if we multiply that by the 50 times, we would get 1.38, or an estimated of 1 time. So the theoretical is about 1.5 times out of 50. The experimental let me fix that, is 3 times out of 50. So the experimental was double the theoretical. Okay. Oh, let me move that up so make sure you can copy that. Okay. All right. And that is our lesson for today.